Hello, everyone. I'm glad you're back from the break, and I don't actually know why we're talking and not just listening to how to make alcohol, but either way works. I'm Luke Church. I'm a user experience researcher, and apparently I'm also a coffee mug.
I'm Devon Carew. I'm an engineer on the Dart team.
And so what we're going to talk to you today about is about how to build production Dart apps with an open source workflow. Nice long title. What that actually means is how it is that you can use services that other people have built to make it your lives easier. And we're going to use DartPad, an application we built as an example. So, what is DartPad? DartPad is a place that you can go to write little snippets of Dart in a browser. And frankly, if you don't actually want to listen to us talk, just hit that URL and have fun for the next half an hour. That'd be great. So we built this for a couple of reasons. It's really important for the Dart ecosystem to have a place where people can write little snippets of code. They can try something out that's independent from their production workflows. And you can write little snippets of code, share them with other people as a way of explaining Dart to people. So this just makes the ecosystem work better. It makes it a little more efficient. The point to stress today is that everything you see here, you can do at home. So we're not using any special magic here, well, maybe just a little, but it's all built out of services that you can build to build your production apps today. So very briefly, DartPad is split in two parts. There's a user interface that comes from the DartPad repo, and there is a Dart services library that runs on AppEngine, and it provides things like compilation, code completion, analysis, and you can use, we split it up this way so you can use either of these two bits. So if you want to build your own DartPad, you don't need any of our UI. You can just use these services. You can also connect the UI to something else. So what we're going to talk about today is how we made sure that this actually works and is actually fast. So the agenda, lots of stuff. We're going to cover all of these, and I'll start off by handing over to Devon to talk about continuous integration.
OK. Let's say you start a project. You already have a bunch of code. You have some unit tests written. A couple developers, and maybe you plan to get pull requests in the future. You want to get some rigor around this workflow, and the way you want to do that is using continuous integration. So it's basically a system. I'm sure many are familiar, but it automatically runs your tests, builds your app, and does it automatically on every commit so that you have a very good visibility into whether the code you're committing is functioning, either you or your team members. There are a couple of good systems to use, continuous integration systems for a Dart app. Travis CI recently got Dart support. Drone.io has had Dart support for a number of years, and if you're interested in getting visibility into your Windows testing, AppEngine has an easy system for getting Dart support. We're using Travis on DartPad, so I'll talk a little bit about getting it set up with Travis. You just need a tiny metadata file on the root of your project to basically tell Travis that you want to use the Dart runtime when you run your tests, and give it a pointer to the script that will actually run your tests. And the scripts typically do a couple of things, like analyze your Dart source code to look for errors and warnings, fail the build if there are any, and run your unit tests. So here's what it looks like, a typical build. So we got a pull request into the DartPad UI. It shows you the build output live in real time. It tells you whether the build passed or failed and notifies you by email. Here's our build history from a few weeks ago. So you get to see, again, like each pull request, you get a green light, red light. And just to sort of validate using it, these are the results as of a week or two ago for DartPad, where the UI project had about 200 pull requests, 400 builds, and 30 failures. And the service backend had about 100 PRs, and again, failures. And the good thing about getting those failures is those all happen in pull requests. So you get visibility of that, and every time we merged code to master, we knew that it was working. So master always stayed clean and shippable. So next we're going to talk about, and what we had running initially on Travis was our unit tests. So Luke is going to talk a little bit about some functional testing, another type of testing.
Sure. So, functional testing. Well, why would we want to do it? So I heard a rumor on the internet that not all browsers behave exactly the same. I mean, it might be news to a lot of folks here, but you can see a browser not quite behaving as we would expect on the screen in front of you here. This isn't person trying to use this isn't going to have a good day with DartPad. Noticeably, they can't actually write code. Bit awkward. So it's really useful to be able to know that ahead of time, and to be able to have a way in which we can verify the behavior that we're handing to all of our users, independently of which platform they're running on, in a way that doesn't result in us having to do that testing manually, one browser at a time. So we've been using a service called Source Labs. A few others you could use. There's browser stacks as well to do this. And what Source Labs enables you to do is two things. One is that you can spin up from a large collection that they offer you, an arbitrary environment. And you can play with your website in that arbitrary environment in a manual way. So what you can see here is checking that the basic functionality of DartPad works in Internet Explorer without me having to go and get a Windows machine. This is really useful. So that gives us the ability to quickly test on a number of different platforms. You can also, however, add things that do automated verification. So if you add this piece of script here to one of the test libraries, what this is doing is spinning up a web browser, reading off the title of that web browser, and verifying that the title is as expected. So we can write this once, test it locally, verify that it's working on our platform, and then, via the magic of Source Labs, have it scale out to test and run across all of our target deployments in one go. So this is how we're ensuring that the product that we're shipping to users across the browser platforms we care about is behaving as we would expect as we add features.
Awesome. So that was functional testing, and I'm going to talk a little bit about code coverage now. Why is code coverage good? So we have a green light, red light for our build right now, and that's awesome. But we don't really know how much we can rely on that green light. What is it really telling us? So for that, we get a little bit better information if we add code coverage to the process. So that tells us really how much of our code is being tested, and if we can really rely on what a green build when that happens. So how? So we're using a Dart package called Dart Coveralls and a hosted service called coveralls.io to get our code coverage information on each build, on each pull request. It's a simple setup. Basically, this Dart Coveralls package runs your unit tests, uses the observatory protocol to collect coverage, formats in a way that Coveralls likes, and uploads it to Coveralls with the commit information. We can take a look at what that looks like. So this is our site on Coveralls, and this is, again, each pull request. We have visibility into the coverage and whether it's increasing or decreasing. You can dig into the results for a pull request and see file by file your coverage, which ones are well covered and which ones maybe aren't as well. And into a file, you can see line by line. So we can see that this method that actually should have had coverage and we probably expected it to have been tested wasn't actually being tested at all. And something important to remember, like we had a very nice measurement there, 81%. It's nice to have more coverage, but you shouldn't really be chasing a specific number. You want to go for quality tests.
It's a bit higher than 80 now, though, I think.
87, yeah, but we're not chasing a number.
No, in any way whatsoever.
But basically what it does is it gives you visibility into how well it's tested. So you may choose not to add tests for getters and toStrings and things that really don't matter or aren't going to fail your testing the compiler, but really it gives you visibility into things maybe you thought were tested that aren't. Or I could get a pull request from Luke with some great back-end services that really decreases the coverage, and I could say, why don't we add some tests to that?
Yeah, not that that would ever happen.
Just to jump back to Coveralls, it does have some nice trigger notifications if your coverage drops below a certain amount or drops a certain amount in a pull request. You can get proactive notifications about that. And I'll hand it back to Luke. He can talk about web hosting and scaling.
Okay, so the position you're in now, looking through this list, is that you've written some code, you've written unit tests for it, you've written system tests for it, and you have some sense of how much of your application is being tested by your various test suites. That's great. So now the question is, how do you actually get that to users so they can do things with it? So we use AppEngine to do this. We actually split the project into two parts. As I mentioned earlier, one of the ideals here was that the Dart services should be usable by people who don't really want any of our UI. They should be able to use it as a standalone component. So we split AppEngine accordingly. So we actually serve static files, CSS, HTML, compiled JavaScript to users from one instance, and then we serve services from another instance. That does analysis, completion, compilation, quick fixes. Okay. So what that does is gives you an application that runs in a web browser and does the right thing. So hosting. And the way in which we handle the services is using the RPC package that's been written. So we get a request in via something that looks like API v1 analyze. The Dart on AppEngine routes that to a managed VM. The RPC package then allows us to select one of the endpoints that we use for providing those services, compute the results, and hand it back. This is all nice and well. However, we're running a compiler and a bunch of developer services in a browser. It is really, really important that that is fast. So what you see here is what it would look like if we hadn't thought about scaling whatsoever. So you can see the blue line is an increasing level of QPS being sent to the compile endpoint, and the red line is the latency, and the big scary red lines are cases where we would have handed back HTTP 503, sorry, come back later, we're broken. This is clearly completely unacceptable. And so we've put in a bunch of work to making sure that A, the system is robust, B, it scales, and C, it remains fast. So there's a couple of things that we've done to make that work on AppEngine. The first one is memcaches. So it turns out that what generally happens with something like DartPad is someone writes a small piece of code, then shares it with a bunch of other people, who also try and run that code in their browser. That code is exactly the same as it was the first time, so the compiler will give you the same result. So consequently, rather than recomputing it, we store that in a memcache and just immediately hand back the results. That cuts the compile latency down to essentially the network latency. And to give you an impression of how effective that is, we get memcache hits on between 88 and 90% of our requests. That cuts a huge loading out of the services. The second really important property here is that you have to keep the virtual machines warm. So you have to reuse as much of that state as possible, whilst also maintaining integrity between your user sessions, so you're not leaking information. And we do that in a couple of ways. One is by hanging on to a bunch of objects, and the other is, as we'll talk about later, we use an uptime service that sends us a continuous trickle of requests at a fairly low grade, which keeps the virtual machines hot. And so what's the effect of that? I mean, we heard a talk earlier talking about 50th and 90th percentiles. So typically, from the server point of view, we can return an analysis in an average of 16 milliseconds. And the 98th percentile, so the people who are having a bad day, are at 54 milliseconds for analysis. We're currently looking at ways of shrinking that a bit, but that's the kind of numbers that we can talk about, which means that when you use DartPad, it should feel pretty much instant for a lot of cases. Compilation is a bit slower, again, but you're still looking at a fairly reasonable, even for the 98th percentile, you're looking at it taking 2.9 seconds to compile and hand you the results back. Again, looking at ways of shrinking that a bit, but it's still within a reasonable performance for feeling fast. And you can compare that to the previous graph where, if you don't care about scaling and latency at all, your compile times are up into the 40, 50 seconds when things start going wrong. And the thing that we'll see later on is that these are useful numbers to understand. They're numbers to understand for the actual server performance whilst we're doing compilation. But what we really care about is end-user-facing latency. And our average compilation latency is 650 milliseconds. That's partially due to an addition from the network traffic, and it's partially due to, as we were saying, Memcache taking out 90% of the queries. So that's how we get code to users fairly quickly. Devon's now going to talk about how we make sure that we keep it quick.
Yeah, so I'm going to talk about some hosted metric services. We've done some work to make the backend fast. We have benchmarks running on each commit and tune the backend. We've actually done some work to make the front end fast, which basically means we don't serve up many bits, or as few bits as possible, and we make as few requests as possible when we start up. So we use dev tools to optimize our loading. We're compiling our JavaScript minified. And that's great, so we're fast, but generally things won't stay fast. Your code's going to bit rot, and unless you actually watch the back end and the front end performance, your speed's going to degrade. So how do you keep it fast? And that's you want to measure it, basically. On every commit, you want to measure your performance metrics, and we're using a hosted metric service called Librado. There's some other services out there like it, but you can basically post your metrics on a build to this service, and then go to it and view your graphs of the metrics over time, which can actually be very powerful. So this is how you get it set up. There's a Librado library, but it's just basically a simple HTTP post of arbitrary metrics data. In this example, we're measuring the size of our compiled desktop front end and mobile front end and uploading those. And here's what it looks like at the Librado site. You can see we have over a dozen metrics. The front end size, our back end benchmarking times in terms of times to compile, times for code completion, times for analysis, and an actual benchmark from a few weeks ago. Our compiled desktop size, you can see we ran at about 350K for our compiled size, except we had a huge spike there when it jumped to almost 700K. What happened there was we imported a library which transitively imported lots of other Dart code, and our front-end size doubled. But having a service like this lets us track these like significant regressions very quickly and identify the git commit that caused it. But it also helps with a lot more subtle things, where over a month maybe your size increases by 10%, and you can identify 2 or 3 commits that each added 2 or 3%. Having visibility into these regressions is very powerful. Luke is going to talk about uptime monitoring to round us out.
So what you're in a position now is that you have your application, you're shipping it, it's working, you know that you're not regressing code size as you go forwards. This leads to another question, suitable for keeping web maintenance people up at night. If your site goes down, how is it that you would know that you're no longer serving to your users, you're now just throwing error messages at them? And in order to find this out, you can use uptime monitoring services. So we're using a service called Pingdom. We've used a couple of different ones, StatusCode, for example. So what these things allow you to do is request that the service sends you a continuous series of data points. Roughly speaking, I think in this case we configure it as to 1 per minute, saying, OK, perform this code completion, do this compilation, do this analysis. And it allows you to track both any times when you get outages. You can get proactive notifications, SMSs, emails. It also allows you to track any creeping latency problems, or any latency problems if you get a report in of your site was really slow. Understanding whether that was slow because of the services or slow because of networking issues is really useful. So we use uptime services to do this. It also, as I mentioned earlier, it sends this low-grade continuous trickle of requests into your system, which if you tune carefully means that the frequently hit paths will be warm whenever a new series of users turn up. So you get that continuous keeping the system productive. So that gives us basically a summary of how do you build an application, how do you make sure it's reliable as you're building it, how do you ship it to users, and then how do you make sure that it's keeping working and keeping serving your users with the experience that you want to. So over to Devon to wrap up.
Cool. Yeah, so I think a takeaway from this talk, hopefully, is that Dart works today with a number of hosted services. These services can be really valuable for your projects. If you want to see examples of how we actually hooked up these services to continuous integration and other systems, you can look at the DartPad repo, GitHub/dartlang DartPad. And we'd like to take a moment to thank some of our open source contributors. We've had some significant contributions in terms of our code completion UI and some other functionality from external people. Yep. One other thing to announce, we're shipping 1.0 today of DartPad, so go use it. There were some DJs around somewhere, weren't there? Where did they go? So, unless they tell us otherwise, I think we have time for questions. No microphones, so.
Nope.
Okay.
Sure. So the question is, just for the record, do we have a roadmap for the near future? Yeah, we should add some features. That'd be good, wouldn't it? I think we planned a bit of a UI redux. There's some stuff on mobile that we'd like to make a little bit better. That'd be great.
Yeah, we support sharing today using GitHub GIS. It uses an anonymous API, which means you can create GIS, but if you want to update it, you have to fork an existing GIS. So we're going to add some OAuth authentication to it, so you can update any GIS that you create or fork other people's. Yeah, we're going to do probably a UI redux of the desktop and the mobile. They're two separate applications right now, completely separate UIs. And we want to unify that probably around a material design look and feel. So,
yep. I'm also kind of interested in whatever it takes to get people to learn a new programming language. It's kind of a research interest. So looking at what we can do around smart suggestions. So we already have a bit of a documentation discovery support, but I think because it's more intended for small snippets, we can probably do things that are quite a lot smarter than that. So looking at putting some of those experiments in, seeing which ones work, it's on the plan.
Are there any plans to make like an embeddable little try it out thing, or like if I have a blog and I want to
Sure. So the question is, are there any plans to make it embeddable? So if you just want to try a little bit out in your blog, could you do that? I think it's certainly something that we're very interested in doing. One of the reasons to split the strategy up this way was to mean that if you wanted a completely different UI for doing that, all the services are available for you. But yeah, we're kind of interested in doing that, particularly around docs discovery on API.line. We'll see how that plays out.
I can be your question buddy if you guys want.
okay.
Sure.
Are there more questions? I just killed your vibe, I'm sorry.
All right.
Yeah.
We have time for more, right? We have a couple.
I have no idea. There's no clock here. I have no idea how long it's been going on for.
Yeah, you
5
got
minutes.
time for a couple more questions
Okay.
if you guys. Yes, no questions? Anyone? Yes, let me bring you Mike.
Thank you. Any plans on collaboration, adding collaboration feature? Two guys could code together.
Oh, collaboration. So the question is, do we have any plans for adding collaborative editing or? Yeah, it's not in our roadmap. I think it'd be an interesting use case, but yeah, DartPad serves a good purpose right now of learning Dart on the web and being able to share snippets. And collaborative is interesting, but it's definitely not something we're actively working on. So
The code is open source, though.
yeah, pull
Can you
requests.
add autocomplete to Google Docs and then just call it done?
Yeah, yeah.
Yeah, collaboration for source code is really hard. There's a lot of very complex workflows that people engage in, but it would be fantastic if somebody else felt like trying that out as an experiment.
Any more?
You mentioned that you run benchmarks on every commit, which is something our team should definitely do. I was wondering what frameworks and services you use to do that.
Yeah, there's a benchmark harness package, which we were using for a while. It's available on GitHub. It supports synchronous benchmarks, which is great unless you need to return a feature. So we basically have a small internal version of that, which warms up whatever code you need to benchmark, warms it up for a while, and then runs like 10 of them, divides that number. So you can actually see the benchmark on our GitHub repo, but benchmark harness is obviously pretty tiny. You just want to do it right, and then yeah.
So does that run with Travis CI and then post the results somewhere?
Yeah. So our build script on Travis basically analyzes the Dart code, look for errors and warnings, runs our unit tests, runs the integration tests via Sauce Labs. Everything looks good. It gathers code coverage information and ships it up to Librado, and it also runs the benchmarks and ships that. It ships the benchmarks to Librado, and code coverage should cover all. So yeah, our benchmark script is like 40 lines long and does a bunch of our build script. does a bunch of things. So, yeah.
We also run separate out-of-band, much more intensive testing before publishing each new major revision of Dart services. We run a large collection of basically all of the .lang suite of tests over it, but that takes multiple tens of hours to run, so we don't run that on every commit.
How long does your CI take right now?
Question was, how long does the CI take?
It's like a few minutes, isn't it?
Yeah, I think I used to know more, but it's 3 or 4. It turns around pretty quickly. So.
So, as usual, the default thing that I say at the end is these guys will be around and would love to have you come talk to them if you see them, if you have more follow-up questions.
Absolutely.
Thanks, guys.
Thank you.
Thanks.